probably a little shaky, and we could use you to help stabilize everything. And I said, well, I can't do it though, because I won't be there a lot because of Katie's club ball. And they said, no, that's all right. He'll take the times when you're not there, and it'll be fine. I said, all right. So the draft is tomorrow night. Yeah, it's for real. I mean, everybody gets drafted. It's Little League, so it's not, but here's all the charts and scores and everything. I mean, we ain't messing around. Well, we kind of are, but yes. It's my double secret draft. And so an hour ago, I get a text from my co-coach, because we're trying to strategize for tomorrow night. And he goes, I've decided I'm not going to coach this year. Yeah.
You got the text today?
Yeah, like an hour ago.
Oh wow, okay.
I was talking to him on Saturday. The last round of tryouts were on Saturday, so we were there. Yeah, well, so that we can rate the players, just so that, to try to make the teams even is what it really comes down to. And then all the coaches want to win anyway, so they want to get the best team they can. But you want it to be fair, so they just do it that way. So now I'm like, okay, now what am I going to do?
So you guys talked about the whole plan and everything, and you just couldn't?
Yeah. At least that's the way I'm seeing it.
Yeah.
I'm like, boy, he must really not have liked me.
Wait, so did you
11,
start
12.
this whole team because of him?
No, there are, excuse me, there are enough girls to have 4 teams in the league. And yeah, it's a pretty small little league. I mean, softball-wise, it's one of the bigger ones, I guess, in the valley, but it's still fairly small. So there are 4 teams in the league, so they need 4 coaches. And they have 2 have been around for a while, another one's moving up from the minors, he wanted to do it, and they needed a 4th. And so this guy said he'd do it, et cetera, et cetera. Yeah, so it'll be interesting. So, tournament this weekend, some of you may have heard, this past weekend.
It's a math problem.
No.
Oh.
No, I'm trying to incorporate the 2 things together so that I keep progressing. But, yeah, tournament this weekend. Remember that there was one 2 weeks ago that Katie's team won?
Yes.
And Katie got the walk-off hit? No, well, this is, somebody asked for question number 21 from homework.
Oh, yeah.
So this tournament was harder than the one 2 weeks ago, but they played really well on Saturday, so they got a high seed for Sunday. They won their first game pretty easily, but they got a really unlucky draw, and in the second game they played this really good team who's beaten them twice. We were 0-2 against this team. Well, we played great. Katie hit a rocket of a single and then a bomb over the outfielder's head later for a double, and we won 6-4. So we made the semifinals. We were losing, we came back, and we won 5-4. So we made it to the finals again against this team that was really, really good. And we used to be, but somehow, no, well, her middle school team, her school team was terrible, terrible. So that might be. But the club team was like 3-11 at one point. Yeah. And they, you could see that they had potential, but they hadn't gotten there yet. So they made the finals against this team that's really good. So we're in the 5th inning. How many denominators, by the way? What's the first one?
X-1.
What's the second one?
X-1 squared.
Perfect. Excellent. Okay. So I'm just going to run while I talk, if that's okay. So we're in the 5th inning. We're down 2-1. We're playing great because we're still in the game against this team that's really good. LCD is x minus 1 squared. So what do we have to multiply this by?
X minus 1.
There you go. 8 times x minus 1. What do we need to multiply this by? Nothing. So what's that? Make sense?
Did I really just use glitter pen on short laser? I think.
I like that equation. That's easy. And then we have to get negative a plus b equals 1. God bless you. Well, we already know a, so therefore b is 4. Therefore, there it is. Sound okay? Typically, in the ones that don't have anything weird, it's just first factor, second factor, however many factors there are. When you have a factor that is squared, and we're going to do a problem in a minute that will kind of help you, I think, see it a little bit better. When you have a factor that is squared, you have to do the factor and then the same factor squared. And if it were cubed, you'd have to do x minus 1. If that were cubed, you'd have to do x minus 1, x minus 1 squared, x minus 1 cubed. You have to do every one up to that. Yep. I didn't hear the last part. If, like, no, go. Like what?
Is that seeing if it's like to the first power?
Then we just have to do it the one time.
Why do you multiply a by x minus 1?
Cool. We're trying to look and see, this is our common denominator. This will always be our common denominator. So what do we have to multiply x minus 1 by to get our common denominator? So since this is x minus 1 squared, we need to multiply by another x minus 1. And so since we multiply that by x minus 1, we have to multiply that by x minus 1. Is that good? Others? Any other problems? That's pretty much what I've done in every class. We did 21 and then jump on and do stuff. So anyway, we're down 2-1 in the fifth. 1 out, 2 outs, 2 outs. Katie comes up. Katie walks. She gets on first base. Okay. Didn't get a hit, but it was four bad pitches, 4 balls. So she's on first. She steals second. They try to throw her out and throw the ball into center field. So she takes off for third. They try to throw her out at third. They throw it away. She takes off and scores the tying run, 2-2. So,
Yeah, it looks like
good job, Katie. So now that's the, we don't get anything else in the fifth. So now we go to the last inning, the sixth. And they don't score. We get out of a little jam, and we come up, and there are runners on second and third with 2 outs. And Katie comes up again. Same, I don't know. It's softball, so you can't pick or anything like that. It's just whoever's up is up. And I had said to my wife the inning before, I said, Katie might have a chance to win it again. And she smacked me. Like, don't say that. So, sure enough, Katie gets up with a chance to win it. And singles in the championship winning run again. Scores, the place goes crazy. Huh?
Katie the goat. I don't hear nothing else about no other team is doing that.
I said to her yesterday at some point, I said, 99.99% of people never get an opportunity, never do that once in their life. And you've done it twice in a row. That's pretty cool stuff. So anyway, no, she, up until a couple of weeks ago, she was having trouble getting on the field on Sundays. Like, they would bench her on Sundays because they didn't think that she was one of the best 9. on their team of 13. I always internally disagreed with that, but I'm not the coach, so I sit back and watch. Yeah. Now, 2 weeks ago, she did so well defensively that's why she was in the game, and then all of a sudden she started hitting better, and now I don't think I have to worry about whether she's going to play on Sundays anymore for a while. So it's pretty cool. They have a tournament in 2 weeks, and then their tournament after that is in Vegas. So, pretty cool. X squared plus 5x plus 4. Over x minus 2 times x squared plus 2. Okay, still partial, oh, she erased it. Partial fraction decomposition, still.
Okay. So factor. Wait, no, the top doesn't matter.
We don't need to factor the top.
Yeah.
In fact, we don't want to factor the top. That'll just mess us up. So the bottom is done being factored, or is there anything else we can do? We can't factor x squared plus 2. So we would call that a irreducible quadratic factor. Cool. So we're getting ready to rock. How many fractions will we have?
3.
Unfortunately,
2.
I respectfully disagree. What's the first one?
X minus 1.
X minus 2, I would agree.
1.
What's the second one?
X squared plus 2.
Do we have any factors to a power? No, so that's it. That's all we need. What's that?
What about the third numerator?
We don't have a third numerator.
No, I mean like the 3 term.
Well, hopefully it'll work itself out.
I don't know.
But we can only do what we can do here. So hopefully it'll work itself out. But yeah, we have this, doesn't have a power, so that's all. We have this, it doesn't have a power, so that's all. So we just have our 2 fractions. What's the numerator of this one?
A.
What's the numerator of this one?
Bx plus c.
Okay, good. Because it's that irreducible quadratic factor, we have to do the bx plus c. Now you see we have the 3 variables, which will probably somehow result in that stuff coming up.
Wait, why is it irreducible?
Because we can't factor x squared plus 2. Okay, now what? Oh, yep.
Oh, if the denominator on that was x squared like minus 2, would that change the numerator? Would it be like bx minus c or?
No, I mean, because if c is positive, c is positive. If c is negative, that's okay. So no, I always do it plus, because that way it's easier. If it's negative, then we know it's a minus. You know what I mean? Okay. All right, now what? LCD. What is the LCD here?
X minus 2.
It's this, right? It'll always be this. I mean, this is where we got all of the denominators from. So if it's not this, we messed up in the first place. So to me, I'm just always going to that. Okay? So, what do we have to multiply the A by?
X minus x squared.
X squared plus 2. Right? We have the x minus 2. So we need to multiply by x squared plus 2 to get it. Okay? Plus bx plus c times x minus 2. Happy with what I wrote?
Yes.
Yes. Everybody good?
Yeah.
Cool. Except that it's not. I don't like what I wrote. In fact, I messed it up. What I do wrong?
I did wrong too.
Or what should I have done that I didn't do? Parentheses around what? Bx plus c. Because bx plus c is being multiplied by the x minus 2. But the way it's written right now, only the c is. So be careful. Make sure that if you have a numerator like bx plus c, that you parenthesize it. Now are you happy with what I wrote?
Yeah.
Me too. Yeah, that was, yeah. I thought I was happy last time, but now we're good. All right, what's the next move? Distribute. Multiply stuff out. So, ax squared plus 2a.
Bx squared.
How are we?
Foil.
We gotta foil this, okay. So plus bx squared minus 2bx
Plus
plus cx
minus 2c.
minus 2c. And now it seems to be about the time to write in bx squared plus 5x plus 4. How we be doing? Circle the squares. Interesting. I like that. I tend to use the phrase gather terms.
Circle the squares.
What do you want to gather first?
The square.
X squared makes sense. So I see an x squared there. I see an x squared there. I see an x squared there. And that's all I see. So, yeah, I like to put the variables on the left and whatever. That's kind of the way we see more of our systems. So A plus B equals 1. Are we okay with that? Are there questions on that?
Yeah, wait, why is it 1? Oh, because it's in front of the x, okay. Got it. Yeah,
Yes?
yes,
Cool.
okay.
All right, what's next? Gather x's. See that? See an x there, and I see an x there. Which gives us negative 2b plus c equals 5. Hopefully everything left is a constant. In other words, does not have any x of any type. So what do we get? 2a minus 2c equals 4. I strongly recommend that you make some type of notation, some types of marks, whatever it is, to do the same type of thing that we did here. Okay, I use different colors, you may not have different colors, but maybe you circle one and underline one and scratch one out or something like that. And then that way, because the biggest mistake that you're likely to make here is the setup of the system. And most of the times when people do that, it's because they either just forgot a term or they put a term as an x that shouldn't have been or something like that. Now the good news is that what are our answers typically when we solve these? Yeah, whole numbers, integers. Yep, they're typically integers. So if you start to get some fractions, I'd kind of take a look back and just see if you mess something up. That's what I would do. I would throw it into an augmented matrix. If I can do things by hand, I'll probably do them by hand, but this just seems like it's more of a pain. So I'd probably just throw it into the augmented matrix.
This got messy. Oh yeah, this doesn't dry for like 8 years. Have some glitter. Okay. Nice. That's an augmented by.
For A. So you're saying I'm right?
Yes.
Love when people say I'm right. Never happens at home, so. What's the easiest part of that whole problem now? Yeah, solving the system of equations. Think about that. Yeah, but, yeah, no doubt. But the fact that you can throw it into the calculator and you know how to do it and it's a nothing to you, that's a good thing. We're actually going to do one in a minute that you're going to see is going to be a huge thing, and it's going to be easier by hand than a matrix. Trust me. Trust me. Questions on this? We got an A of 3, a B of -2, and a C of 1. Okay, 3, -2, 1. Page. This was question number 28 from your book. Your homework for tonight goes up through question number 27. Okay, so it shouldn't get harder than this. Now that being said, let's do something crazy.
Okay.
Why?
Because it'll be good. It will.
I think this is plenty crazy for the day.
All right, anybody still
I
need
say
this?
colored pencils right now.
Because I do need the space, so I need to erase this. And nobody needs it? Anybody? I believe that, for me, it will definitely take pretty much the entire board. Which means you can kind of figure out what it's going to take for you accordingly.
It's going to take me an entire board. I'm just going to write 9.4.
Oh. Where does everything in math, how does it have to go together?
Wait, it depends on what the denominator
Hold on.
Over.
Oh, that's not you.
How about no thanks?
My theory on this one is, I was going to say if, but when we're done with it, I'm going to say when you can do this one, all the other ones will seem simple. All right. That's a when. All right. What do we start with? Denominators. I would agree.
I don't want to.
What is our first denominator? X is correct. But do you know why it's x rather than x squared? That's a shame. No, but you know this. This is the same as the homework
Should
problem
be x
we just
then
did.
x squared.
Right? This is a factor that's being squared. So the first denominator is x. What's the second denominator?
X squared.
Second denominator is x squared. Okay?
Oh.
Yeah.
X squared plus 2.
Third denominator is x squared plus 2, right? And what's the...
X squared plus 2
X squared plus 2 squared.
Okay. Are there questions on that? Does that make sense given what we've been talking about and doing? Right? We have a factor, both of those factors are squares. So we have to do the factor and the factor squared, then we have to do the factor and the factor squared. Okay? Numerators. A, B, CX plus D.
What's that?
I love how does it EX plus F?
Why are we
That was more a, oh God, please tell me I'm wrong. Was I right? Am I right with that?
Yeah.
Yep.
How come all the other ones except for B have like an X plus
This is not, I couldn't set it.
Better not knock over my
I want
phone.
to make sure I phrase this correctly. Okay. These are binomials, irreducible quadratic factors. So x squared plus 2, x squared plus 7, x squared plus 1. We can't factor them. Anything that's an irreducible quadratic factor is going to be blank x plus blank. So cx plus d, ex plus f, ax plus b, whatever it needs to be. This one, because it's not a binomial, all we need is the one term up top. So anything that's going to be an x will just have the one term up top. Anything that doesn't have an irreducible quadratic factor will just have the one term up top. Okay. All right. Other questions here? Okay, what's next? What's the LCD?
X.
That. Yeah, that's the way I'm going to say it. I'm going to say that. Why is it that? Because
it's that.
it's always that. That was easy. It's always that. So now, what do we do next? I don't know what you mean.
You have to multiply what you don't have.
Multiply what?
Numerator.
Numerators. So we got to do our numerators. Okay? We do our numerators by basically talking about the denominators. In other words, what are we multiplying this by to get this?
X.
And that's what we have to multiply the top by. So you said we're going to multiply by x times x squared plus 2 squared. So here we have an x, here we have an x squared, so we need an x, we need another x, and then we need this whole thing also. Is that okay? Questions? No. Okay. B.
X.
So just the x squared plus 2 squared. Right? We have the x squared here. We have the x squared there, so we don't need anything there. We just need this whole thing. Okay, now what? Plus cx plus d in parentheses. Good. You know me. I try to mess up every once in a while to make sure that everybody's understanding. That was the master plan. All right, what do we have to multiply by?
X squared times x.
X squared times
X squared plus 2.
x squared plus 2. Remember, here we have an x squared plus 2, but here we have x squared plus 2 squared. So we need another x squared plus 2, and we also need this x squared that's out here. We okay with that? Plus
EX plus F, parentheses,
EX plus F,
You
times
sent.
X squared.
just the x squared?
Yes.
Oh, cool. That's not that bad.
You subbed it.
You just multiply what you don't have.
You
Yep.
sent it.
All right, so that's a big mess. By the way,
Sounds fun.
I know you don't want to hear this, but I'm going to say it anyway. There is no shortcut here. You just have to grind it out. Okay? And there's a lot of stuff, but you guys can do all this. I know you don't want to, but tough noogies on that one. You just got to, and I think if you know that you just have to do it, that you'll do it. So you just have to do it. All right, what don't you like up there? There are a couple of things that I don't like, but one in particular. There's a lot of squares and x's and x squareds and stuff like that. What would be, no, we can't get rid of anything. I told you, we just have to grind it out. That's the whole point of there's no shortcut. Okay? You can't get rid of stuff. You can't simplify. You can't cancel. You just have to do. All right? What don't you like the multiplying part? Is there any part of the multiplying part? X squared plus 2 squared. I don't like that either. So what I'm going to do is I'm going to over here discuss or figure out what's x squared plus 2 squared. So what is x squared plus 2 squared? X to the 4th.
Plus 4.
4x squared. Where's that coming from?
Square double square.
Square double square. That's right. 4x squared
Plus 4.
plus 4. Okay, so x squared plus 2 squared is this. Square the first term. Okay, there. Then 2 the way I'm gonna do it this way is I'm gonna do 2 times this times this. It's always 2 times the 2 terms multiplied together. And you can do it in whatever order you want. So I'm gonna go 2 times that, times that. And then the square at the end is the second term squared. So, here we go. AX times x squared plus 2 squared, which is x to the 4th, plus 4x squared plus 4, plus b times x squared plus 2 squared, which is again x to the 4th plus 4x squared plus 4, plus, I would suggest at this point, just distribute the x squared for now. Distribute that, which gives us x to the 4th
plus 2 squared.
plus 2x squared. Sounds good. And I'll just leave this last one the way it is for now. Looks scary, yeah, absolutely.
It's not terrible.
But if you chunk it, as they say sometimes, you just think of a little part. Just do the next step. And if you just keep doing the next step, yeah, it eventually you get to a point where you go, oh, okay, I got this. So what's the next step? Multiplying it out, lots of distributing. So, go.
AX to the 5th is
AX to the 5th
Plus 4ax.
plus 4AX to the 3rd plus 4AX. Okay? Plus
BX to the 4th.
BX to the 4th plus 4BX squared plus 4B plus, ooh, ew. What do we have to do? We gotta foil this. I don't care how ugly it looks, just keep cranking and it's gonna work itself out. So,
CX to the 5th.
CX to the 5th plus
2cx to the 3rd.
2CX to the 3rd,
Plus dx to the 3rd.
DX to the 4th, plus
2dx squared.
2DX squared. Plus
X to the 3rd.
EX to the 3rd
Plus fx squared.
plus FX squared.
Yeah.